So last week, when Anthropic released Opus 4.5, they also released this article, Effective Harnesses for Long-Running Agents, which essentially is their research on how to improve the Claude Agent SDK for long-running tasks. And what's interesting here is essentially what they're saying is they want to make the Claude Agent SDK act more like human coders. Not to toot my own horn, but this is what I've been talking about. I made a video like last week, I called it Stop Vibe Coding, and the whole point of it was there are certain processes and disciplines that if you master, you will get much better output for building things with AI. And what they share in this article is how they went about implementing this in the Claude Agent SDK. Now, when Opus 4.5 came out, they also announced improvements to Claude Code, and one of those announcements was an improved plan mode, arguably a better implementation of the previous version of plan mode, but that new plan mode is not what they're proposing here, at least not yet. This might indicate where they're going next, and I'm very excited to see that. What they're really proposing here is the agentic harness, how they could get the agent to work in a certain way that it will be able to work step by step, implement a plan without running into the barriers of the context window and making a bunch of errors. So I already read the article. I'm going to explain everything to you. Let's get into it. Getting agents to make consistent progress across multiple contexts remains an open problem. The core challenge of long-running agents is that each new session begins with no memory of what came before it. The main bottleneck here is the context window, the short-term memory of the agent. On the one hand, we don't want to have really long chats because that leads to more hallucinations. On the other hand, starting from scratch without any infrastructure leaves the agent clueless. Because context windows are limited and because most complex projects cannot be completed within a single window, agents need a way to bridge the gap between coding sessions. So they propose a two-fold solution that enables the Claude Agents SDK to work effectively across many context windows. And they do this essentially with two agents, an initializer agent and a coding agent. The initializer agent sets up the initial coding environment, pretty much makes a plan, and then a new coding agent is used in every chat to work incrementally, one step at a time. Then they get into the Claude Agent SDK, how it's able to use tools, and that it even does have some context management capabilities. We know this as compacting / compact. What it does is it looks at your whole chat, summarizes it, then clears the chat, and then passes it to the newer version of the chat, which is essentially done automatically once you hit 0% in your context window. So the new chat has some context, has some memory of what happened, but it doesn't work that well. They say here, compaction isn't enough. So then they break the problem down into two main patterns, and we're all familiar with this. One, the agent tries to do too much at once. It tries to one-shot whatever it's trying to build, which often leads to the agent hitting the end of the context window and then starting a new session with whatever it was building half done, not really understanding what's working and not working. And two, the agent looking at the project, seeing all this code and just saying it's done. And if you've been building with AI, I'm sure you've seen this happen a lot. The way Anthropic goes about solving this is they say, we need to set up an initial environment that lays the foundation for all the features that a given prompt requires. Second, they propose prompting the agent to make incremental progress, while also leaving the environment in a clean state at the end of a session. And by clean state, they mean code that could be committed to the main branch. They want each session to write a specific part of the code, make sure it works, make sure it's clean, make sure it's documented, end the conversation and move to the next one. For the initializer agent, they made a specialized prompt that has the model set up initial environment via a specific initialization script, a Claude progress text file, and an initial git commit. So then they could track all the code or files that were added. Sounds super familiar. So once the initializer agent has done its work, they call the coding agent. Each time the coding agent is called, it's there to make incremental progress, one task at a time, and to leave structured updates. The key insight here was finding a way for agents to quickly understand the state of work when starting with a fresh context window, which is accomplished with a Claude progress text file alongside the git history. So one file where the agent writes about what it did, marks its progress as done, and then the git history where the agent can look and see this was done, this wasn't done. And this is exactly what regular human coders have been doing for years. But this is actually where it starts to get interesting. To address the problem of the agent one-shotting an app or prematurely considering the project as complete, we prompted the initializer agent to write a comprehensive file of feature requirements expanding on the user's initial prompt. Translation: the user gives a PRD or a very detailed prompt, and we have the initializer agent write a task list, break it down into tasks. This part is very similar to spec-driven development, OpenSpec, BMAD, SpecKit, but here's the added value. These features were all initially marked as failing so that later coding agents would have a clear outline of what full functionality looked like. So here in the JSON that provided, we see passes is false. And that's what's really interesting. Why is it in JSON? They prompt coding agents to edit this file only by changing the status, and they use very strongly worded instructions like, it's unacceptable to remove or edit tests because this could lead to missing or buggy functionality. And then we landed on JSON because the model is less likely to inappropriately change or overwrite JSON files compared to Markdown files. And that is very interesting. We work a lot with Markdown files. In fact, that's what SpecKit uses, that's what OpenSpec uses, that's what BBand uses, and that's how I'm sure that the new plan mode in Claude Code is not what they're talking about here, because this is using JSON, and if you go into Claude Code and you use plan mode, it's still a Markdown file. Nevertheless, I find this very interesting because the agent feels much freer to go and modify Markdown files, but by writing it in JSON, the agent is much less likely to change it. So given all that, they tell the agent to work on one feature at a time, and then they ask the model to make commits to Git with descriptive commit messages, and to write summaries of the progress in the progress file. This allows the model to use Git to revert bad code changes and recover working states of the codebase. And again, this is what we've been doing. It's very intuitive. You commit often, you write down context so you know where you're at, you know what you've done. If you need to revert or go back to a working version, you have it all listed and you could understand what changed and what you need to do. And then the last step, testing. One final major failure mode that we observed was Claude tended to make code changes and even do testing, but failed to recognize the feature didn't work end to end. This is something you've probably noticed yourself. Even if you build in testing, you use test-driven development with your agent. Sometimes it would just run the test. Sometimes it would change the test. It would say, I passed it. It felt like this huge hallucination, this huge gaslighting, because you can see yourself it didn't pass it. But what it's saying here is it wouldn't even realize that it didn't pass the test. It would just run the test, say, I did it, so it worked. So their solution here is giving Claude tools. And I've talked about using Playwright MCP, Chrome DevTools MCP, Superbase, TestSprite, many different tools that give the agents the ability to look at what they're doing, verify it, and actually see what happened. With all these things in place, when you start a new coding agent session, they run through a series of steps. First, run pwd to understand the directory so the agent understands where it's working and knows that it shouldn't touch any other files or directories. And this seems like a no-brainer, but we've all seen Claude or Codex or whatever go out and change something that it shouldn't. Read the Git logs and progress files to get up to speed, and read the list of features to understand what's done and what it should tackle next. And what they say here is this approach saves Claude tokens in every session because it helps the agent run a basic test before it even gets started to understand where it is, what's working, and if it needs to fix the code first or go on and build the next feature. Because if the agent jumped feet first into a new task without testing and not understanding that it's already broken and then started building the next feature, it would just make whatever problem it had even worse. So everything that's saying here is pretty intuitive. If you've been building things for a while or been working in teams, you know that more or less this is the order of operations that every developer or every team of developers go through when they start working on something. At least that's the best practice. Anthropic is saying, well, AI is really good at writing code, but we need to give it guidelines. We need to understand this is what it should do. And if we provide it the correct harness, then it will perform a lot better. And that correct harness is actually what we've been doing as humans this whole time. To my knowledge and from my testing, it is not yet implemented into Claude Code. A lot of these procedures we can do ourselves right now. Again, I made a video on how to do this. It's more or less the steps you would take to guide the agent to perform to its best ability. I'll link to it above. I really hope that Anthropic adds this to Claude Code because it would be so powerful. And seeing one of the top AI research labs talk about this is vindication. It's a guide to tell us, yes, this is what you need to do. At the end, they have this table of how they solve each problem. When Claude says it finished the project too early, how the initializer agent solves it, how the coding agent solves it. If the agent were to leave the environment with a state of bugs, how the initializer agent solves it, and then how the coding agent fixes it. When the agent leaves a feature marked as done too early, how the initializer agent sets up a feature list. The coding agent would only mark a feature as passing when it's completed it self-verifies. And most importantly, telling the agent how to run whatever it's doing. And that is done via the initializer agent's initialization script. So when the coding agent steps in, it knows what it has to do instead of trying to figure out itself and potentially break things along the way. So I think this is a pretty interesting research paper. Even though we knew most of it, it's good to see Anthropic talking about it. If you have any questions or feedback, drop it in the comments below. If you haven't done so already, subscribe to the channel. It really helps me grow. Thank you guys for watching and have a great day.